Hello guys, welcome back to my YouTube channel. Today we will be solving a couple of geometric questions from CAT 2004, and before each question I would suggest the audience to pause the video and try the question yourself first and then look at the solution. So I will start with the first question. We are given a semicircle whose diameter is AD and chord BC is parallel to the diameter AD. We are also told that the chords AB and CD have lengths equal to 2 units each, and the length of the diameter is 8 units. So we need to find the length of chord BC. So let me copy the diagram, right? Okay. So this point is B, right? And this point is C. Suppose the center of the semicircle is O. We are told that AD is 8. AD is equal to 8. This is basically the diameter. So what will be the radius? Radius will be 4 units. So AO is equal to OB is equal to 4 radius. Basically radii. These are the radii. AO and OD, not OB. OB will also be the radius, but in the diagram currently it will be OD. This won't be OB. This will be OD. I need to find the length of BC, and this is 2 units given. This is also 2 units given. So let us assume that BC is equal to x units, and let me drop some perpendicular, two perpendiculars from point B. Suppose it meets at P, and from point C I will drop another perpendicular to the diameter which would intersect it at point Q. This is 90 degree. So from the diagram I can say PQ is equal to x. Now we know that AO is 4 units. Suppose this is y, this length is y, this length is y units. So what will be this length? This length will be 4 minus y, because the total must be 4. AO is the total, right? AO is the total. AO must be 4. Alright. Now see, this side is equal to this side, right? Then this is 90 degree. This is also 90 degree. And this is the height, right? Since BC and AD are parallel, that means the distance between two parallel lines, or basically the perpendicular distance between two parallel lines, are equal, right? So this equal to this. Okay, so in these two triangles I can say they are congruent to each other. Triangle ABP and triangle QCD. I will write here so that you guys do not get confused. Triangle APB is congruent to triangle DQC. By which rule? Right angle hypotenuse side, RHS congruency. Right angle hypotenuse side rule. These two triangles are congruent. That means what? Their corresponding sides will be equal. That means this side will be equal to this side. See, from symmetry also I could have directly written this as y, okay? But like I personally do not go by symmetry, because in some cases this does not work, although the figure or the figures might look similar, or like there might be some symmetry, but they don't always work. Okay, so I prefer to prove the similarity or congruency between the figures, and then I take the next steps. So what will be this? This will be again 4 minus y. Okay, now I will join these points. This point I will join. Okay, BO. BO is also the radius, right? So what will be the radius for, like, the length of BO will be, length of BO will be 4 units. Now this is a right angle triangle, right? BPO is a right angle triangle. So I can say BP square, BP square, right? Instead of writing BP every time, let's say the height is h. I can say h square plus 4 minus y square is equal to 4 square, hypotenuse square. This is the first equation. And in the second equation, I can say, if I look at triangle AB, if I look at ABP, I can say h square plus y square is equal to 2 square, Pythagoras theorem. Okay, now I have two equations and two variables, so I can find the value of h and y. Third equation, I will write this at the top. See, 4 minus y, this is 4 minus y, 4 minus y plus 4 minus y, this will give me basically x, right? This is x, BC is x. So from here I can say x is equal to 8 minus 2y. So basically I need to find the value of y so that I can find the value of x. So from the earlier two equations, I will have to eliminate h. So it's very easy to eliminate h, right? So from here I can say h square is equal to 4 square minus 4 minus y square, and from here I can say h square is equal to 2 square minus y square. So both will be equal, right? Both will be equal. This is equation 1, equation 2. From this 2 I can say, so 4 square minus 4 minus y whole square is equal to 2 square minus y square. This I can say this is 16 minus 8y plus y square is equal to 4 minus y square. 16 and 16 will get cancelled, plus 8y minus y square equal to 4 minus y square, right? So y square will get cancelled. What is the value of y? The value of y is 2. Y is equal to 2. Y is equal to 2. Any mistake I am doing here, guys? Just let me check. Y is equal to 2. If I put y is equal to 2, 2 into 2 is equal to 4. So 8 minus 4 is 4. So x should be equal to 4. I need to find the length of BC, right? This is 2. We are given this is 2, right? The length of 2 units. So this is 2. This is the height. All right. This AO is 4. So this is 1. This will be 4 minus y. So h square plus 4 minus y whole square is equal to 4 square, which is correct. And h square plus y square is equal to 2 square, which is also correct. So this is y cannot be 2, right? This hypotenuse is the longest side. I'm definitely making some mistake here. Square is 4. My bad, guys. My bad. This is not y cannot be 2, right? Y will be half. Okay, y will be half. Right. See, before using the outcome, the result, always check. So like why the doubt came in my mind. Okay, so See, in this triangle, I already have the hypotenuse as 2. That means what? Y must be less than 2, right? So this can be said that y is equal to 4 by 8, which is half, or 2y is equal to 1, right? Or I can say 2y is equal to 1. Substitute the value of 2y in this equation. From this, I will get x equal to 8 minus 2y. 2y is 1. So 8 minus 1 is 7 units. Hence, the length of BC is 7 units. So the correct answer is 7 units. Correct answer is 7 units. Very good question. Very good question. Let's move to the next question. Okay. So a circle with radius 2 is placed against the right angle. Another smaller circle is also placed as shown in the adjoining figure. What is the radius of the smaller circle? Okay. Suppose let's better to copy that diagram, right? Okay. I will enlarge the diagram so that it's easier to explain. Okay. Suppose this is the center of the bigger circle. This is the center of the smaller circle. I will do one thing. I will generalize this. Okay. Like instead of using values right at the beginning, I will use them at the end. So let radius of bigger circle equal to r, and let radius of smaller circle is equal to small r, capital R units, small r units. Suppose center is, this is our vector. Okay, so they are touching each other. No, this is placed against me. This is touching the sides of the right angle. Okay, and this triangle is like, is the circle? Yeah, this is also touching the sides of the right angle. So this will be capital R. Similarly, this will be capital R. So this is also R. Why 90 degree? Because it is touching it. Radius is perpendicular to the tangent at point of contact. Okay. What can I do? If I join the centers, okay, this length will be R, capital R. Why? See, this angle is already 90 degree. We are told that these red lines, okay, just focus on the two red lines. They are forming a right angle. So, and this angle is right angle because Radius is perpendicular to the tangent at point of contact. Similar reasoning here also. Three angles are 90 degree. That means what? This angle is a 90 degree. That means four sides are, for not four sides, four angles of a quadrilateral are 90 degree each. That means it's a rectangle. But we know that the adjacent sides are also equal, right? This is R. This is also R. That means this is a square. That means all the sides are equal. So this will also be R, and this will also be R. Okay. If I look at, suppose this point is P, this point is Q, and suppose this is T. Okay, so in triangle PQT, triangle PQT, see, can I say PT square plus QT square is equal to PQ square? Yes, because Pythagoras theorem, right? Right angle triangle, Pythagoras theorem I have applied here. PT is R square. What is QT? QT is also R square. PQ I don't know. So from here I will get PQ in terms of capital R. So I can say PQ is equal to 2R square. So R root 2R basically. So root 2 R. PQ is root 2 R. And the two circles are touching at this point, right? Suppose this is point V. Can I write PQ equal to PV plus VQ? Yes. What is PV? PV is capital R only, radius of the bigger circle, plus VQ. VQ, right? VQ. Suppose this center is W is the center. So VW plus WQ. What is VW? VW is basically the radius of the smaller circle plus WQ. And this point is, let me name this as U. I will join W and U. Okay. Look at triangle WUQ. This is a right angle triangle. Okay. I have W as the center. From center, this is W. This point is U, and this is 90 degree. Why? Because WU is basically the radius, right? WU is the radius, and radius is perpendicular to tangent at point of contact. Similarly, UQ will also be equal to smaller. Why? Because they will form a square, right? This point, suppose let me name this as A. This will form a square, right? WUQA will form a square. Similar reasoning as I have mentioned for the bigger circle, right? Three angles are 90 degrees, so the fourth angle will be 90 degree, and adjacent sides are equal, so it's a square. So this is R, this is R, this will be similarly root 2 R. That means WQ is root 2 R, and this is PQ, right? This is our, so I'll just substitute the value of PQ here. I I have expressed PQ in terms of capital R, and in second equation I have expressed PQ in terms of smaller and capital R both. So I can say capital R plus small r plus root 2 times small r is equal to root 2 times capital R. This means if I take small r common, it will be root 2 plus 1. I will take the r to the right hand side and take common, so it will be root 2 minus 1. So what is the ratio of the radius of the radii of the two circles? Small r by capital R is equal to root 2 minus 1 by root 2 plus 1. Very interesting relation. Okay, small r by capital R. So you can remember this is a result. That is when two circles are placed against each other and both the two circles are touching the like the axis. You can say this is an axis, right? XY axis, coordinate axis basically. Then the radii of the smaller circle, the ratio of the radius of the smaller circle to that of the bigger circle will be root 2 minus 1 by root 2 plus 1. And in our case we are told that the radius of the larger circle is 2. That means capital R is 2. R equal to, place R equal to 2. R equal to 2 we are given. So what should be smaller? Smaller will be equal to root 2 minus, if I rationalize this, can I rationalize? I will get root 2 minus 1 whole square by 1. So root 2 minus 1 whole square will give me 2 plus 1 3 minus 2 root 2, and I have to multiply these by capital R. And what is capital R? Capital R is 2. So this will be 6 minus 4 root 2 units. This is the radius of the smaller circle. A very good question, a very good and conceptual question. Okay, not an easy question. I would say this is a moderate, moderate, not so difficult also, moderate. I would say moderate level question, but a very good conceptual question. All right. I hope these two you like these two questions. For more such videos, do subscribe to my channel. Thank you.